as we have done over and over and over and over and over all year long, we take a parent graph and we learn how to move it left and right and up and down and reflect. What makes it reflect? What makes it reflect over the x-axis? A negative sign out in front is what makes it reflect over the x-axis. Now, what I noticed yesterday is a lot of you were having trouble figuring out that B number. So we're going to fix that. The first thing you're going to do on every single problem is you are going to pick up your highlighter and you are going to highlight the asymptote. Please highlight the asymptote on those first two graphs. That would mean you have to pick up your highlighter. Now, do you notice? Wait, I should ask this. Is it growth or decay? It's growth. And do you see that it is above the asymptote? But this one is below the asymptote. If it has been reflected, it will be below the asymptote. Write that in on the second one. The reason it is below the asymptote is because this negative sign is out there in front of the base number. Now, when you are graphing, the first thing you have to do is find that key point. In this first problem, the key point is right there. Make a great big dot on that key point. What is the x value right here? 2 to the 0 power is equal to 1. Do you remember that fun fact from exponents? Anything raised to the 0 power is equal to 1. Anything raised to the 0 power is equal to 1. That's why it's one box, because the x value is 0 and that's equal to 1. Okay, now, how do we find the base number? Because this is what people were having trouble with yesterday. From that key point, where do you go? 1 to the right, and that distance right there is the base number. If you are going 1 to the right, that would be 2 to the first power. That's just the base number. The reason we go 1 to the right is that would be a power of 1. Okay, so over here, do we have a point that's 1 above the asymptote to be the key point? If it's reflected, where is the key point? 1 below, because it's been reflected. So instead of being above, it's below. And there is where we count the B number. The first thing you're going to do on every single problem is you're going to pick up your highlighter and highlight your asymptote. If the graph is below the asymptote, it's been reflected, so there's a negative sign out in front. If the graph is above the asymptote, it hasn't been reflected, so there's no negative sign out in front. Find that key point. From that key point, you go 1 to the right and you count this distance to the asymptote, to the first pretty point. That distance there is where you get the base of 3. If it's been reflected, there's the key point, and if it's been reflected, you are counting in the negative direction. That's why it's a negative 3 instead of a positive 3. What are you going to do? First of everything, pick up your highlighter, highlight your asymptote. If the graph is above the asymptote, it has not been reflected. If your graph is below the asymptote, it has been reflected. Is this growth or decay? Now, have somebody answer that. Do we know why it's decay? If I go across the graph from left to right, did it go down? So, can you find the key point? If I go one to the right, can I count that distance? No, it's too little. So where am I going to count? To the left, 1, 2, 3, that distance right there. When you go to the left, that's -1 exponent. Fun fact from our exponent unit. When you have something to the -1 power, that is the reciprocal. That's why it's a 1/4 instead of a whole number 4. On this one, there's our key point. Can we count one to the right? Can you count that little distance? I can't. So instead of counting on the right, I count over here on the left-hand side. When you count on the left-hand side, it's a reciprocal. Why is that negative sign out in front again? How do you know it's reflected? It's below the asymptote. That means it's been reflected. If you have to count on the left of the key point, it's a reciprocal. If you count on the right of the key point, it's a whole number. Okay, example number 1. First thing you're going to do is pick up your highlighter and highlight the asymptote. The asymptote is at -2. I said that incorrectly. The asymptote is y equals -2. The y equals has to be part of the asymptote, and it's y because it crosses the y-axis. And that's also the k. Next step, find that key point. Where's that key point? Do I have anything up here, 1 above? Is this the key point? Is it below? It's below the asymptote, so this is going to be a -1. The only A's that we're going to look at is either A is going to be +1 or -1. It's either reflected or not. And then later on we'll get into more complicated A's. Okay. What is the X value of that point? Isn't it -4? From that key point, can I count over here on the right? It's too little. So if I can't count on the right, then I count on the left. 1, 2, 3. I count to the asymptote. I'd like to see that on your graph so I can tell where you're counting. So is this going to be 3? When you count on the left, it is a reciprocal. It's 1/3. Did you get that? Did I go too fast? Perla, what's first? Pick up your highlighter. There's the asymptote. Go ahead and fill in the asymptote. Do you notice that I don't start at the top? I usually start at the bottom because I just highlighted the asymptote. So I'm going to go ahead and write it down. Caitlin, what's next? Okay, find the key point, and that's going to help me find the H. Since that is below the asymptote, this is going to be a -1. And so, Caitlin, what's the H going to be? No, not -2. +2. Oops, I put that in the wrong spot. That's the H. Go 1 to the right and count that distance. 1, 2, 3, 4. Now I wrote down 4. Is that right? 4 or 1/4? How do I know? If you count on the, it has to do with up or down. It has to do with right or left. If you count on the right, it's a whole number. If you count on the left, it's a reciprocal. I think I may have forgotten to write down the function on the previous one, did I? Okay, well, let's write down the function on this one. So, the function that it's talking about is, please write that on your notes. I don't believe it's on there, so go ahead and make sure you write that on your notes. And so once you have the little chart, can you fill in the equation? G of x, we use G of x to represent the transformed function. The A is -1, the B is 4, x minus 2 plus 3. Make sure the x minus 2 looks like an exponent. Make sure the plus 3 doesn't. Now, it says +2. Why does it say -2? X is still a liar. Always has been. Okay, on your paper, you fill out problem part 3. How did you do? How did I do? Did I make any mistakes? It's below the asymptote, so this is a -1. I counted on the left, so that's a reciprocal. The x value of my key point, my asymptote is at 6. Got it all right? Have you already done problem 4? Please do problem 4. How did you do on problem number 4? Now, when you get to your homework paper in just a minute, they're not all going to be reflections. They were all reflections. Examples 1 through 4 were all reflections on your notes because that's what the notes are about. On your homework paper, the problems are mixed up, so be sure to pay attention. How do you tell when it's a reflection? The graph is under the asymptote. If it's under the asymptote, this would be a -1.